Thanks, Keith. My name is Correll. I'm a Director of Product Management over at AeroHive, and thanks for attending. I was just talking to David Coleman. He said that I should spend some of my time explaining to you the value of using the Wi-Fi 6 moniker. Just checking the audience, That's what it is, okay. We're going to talk about 802.11 KVR, which in reality isn't KVR anymore. It's been wrapped into the 802.11 spec, 2012, 2016, 2019, whatever comes along. But it's important to understand when we're talking about standards like that, whether it happens to be KVR or happens to be 11X or any of them, what's in the standard isn't really what people use. So if you look at, what's in an IEEE spec, what's in a Wi-Fi Alliance certification, and what the vendors are doing, they're all over the map. And it's important to understand that. So when we talk about 11K functionality, there's probably 10 times more stuff in that people aren't using than people actually are using. The same thing with V, the same thing with R. So it's very important to understand that those of you who really like to get into read these, the 11V spec is 500 pages long. I don't think many of you would bother reading that. But be aware, if you read through all that and saw a lot of the features and a lot of the capabilities, just like with 11AX, and you're never going to see those be used anywhere. It's just different groups of people are involved in doing this stuff. So just kind of understand that from the very, very beginning of what's happening with that. The other thing, too, is things change over time. We'll talk about a lot of the standards that have evolved over the last years about Wi-Fi and about roaming in particular. If you think about Wi-Fi, a lot of smart people in here, the first thing is about association. I want to get connected. And the next thing is about mobility. And when you talk about mobility, you're talking about roaming. What's the difference between nomadic and seamless roaming? See, I make you guys talk. What's nomadic roaming? Excuse me? When you drop, or typically it's like if you're in a class, you open your laptop, you do your work, class ends, you close your laptop, you go to the next room, you open it up, and you connect again. That it's really not designed to be seamless. Where seamless roaming is really more about Wi-Fi, voice over Wi-Fi, and that it's supposed to stay associated as I go along with you. So the whole idea is Wi-Fi is supposed to stay seamless, connected to the same SSID when you roam, without losing the connection. That's the goal. That's the dream. You're always going to lose some. You're all going to drop a little bit about that functionality. So what's the difference between cellular roaming and Wi-Fi roaming? See, I told you I'm going to make you guys answer questions. Well, I can't answer questions at the end, he said. So in the middle, I can. Controlled by the carrier. Typically, when cellular roaming, you make before you break. With Wi-Fi, I break before I make. I got to actually do the disassociation before I do the reassociation. I can actually authenticate ahead of time, but I can't associate ahead of time. So you got to do it. So that's one of the things they've been challenging with all the years and stuff is dealing with this. So with roaming, what's good enough? How fast should a client roam from disassociating with one AP to associating with the next AP? That's actually a very good idea. If you didn't hear it, whatever doesn't break your application. The answer is what depends. It depends. If you're doing real-time voice, you can get up here and help if you want. Thursday, okay. But that's the whole idea. Is that it depends on the application you're doing. Some applications are very, very sensitive. Others, heck, you could disconnect for a week. It probably wouldn't know, depending on what you're trying to do. But the whole idea is to make it as seamless as possible. And there's a lot of tools, there's a lot of capabilities that come along to try to help you do that. The other thing is, there's a big interest right now in what's called the client experience or the user experience. I participate in something called HT&G, which is a hospitality work group, and they're trying to define what that experience is. What's an acceptable level of delay, of latency when you roam, depending on if you're a 5-star hotel or a 1-star hotel? Because, once again, different levels. The Wi-Fi Alliance right now is even starting to have just general feelers of, could we actually do a certification along these lines? It's kind of tough. It's almost impossible to do that because the different clients, the different use cases, the different environments. So it's going to be very difficult to do that. But you're also going to see a lot of vendors do it first. I'm at AeroHive, and this isn't a marketing thing, but we're doing things like, how do I identify what's happening with the client? What are their roaming experience? Can I identify why that roam took so long? And every other vendor is doing that at the same level. So that's kind of where we are right now. So the idea today is kind of understand what's going on there, understand where the industry has gone. And, roaming is a tough subject. A lot of people have different ideas of what it is. A lot of people have different ideas how to design for it. What's the appropriate overlap and what the RSSI level is. You could have religious discussions about that, and that's really not what we're going to have today. So that being said, kind of moving along, one other comment I want to make is doing the 11R stuff, I got more into authentication and key management than I ever wanted to do in my entire life. And to those of you who enjoy that, I'm very impressed and slightly saddened, because it's unbelievable. I mean, some of the stuff David helped me with, it's like, I only had to read, I think, 14 times to understand what they were trying to accomplish. But we're going to talk through that, and I'll actually explain it to you as we go along. So that being said, important thing to understand when we start to talk about roaming is, how does a client roam today? How does it work? I'm associated to a client, fat, dumb, and happy, everything's good. When do I decide to roam? What makes me decide to roam? You're going to hear that a lot. Depends on a lot. Typically, it's going to be RSSI. My RSSI is going down here. Maybe I can hear another AP with a higher RSA, but vendor-specific stuff. It could be CRC errors. It could be lost packets. I could have missed some beacons. It could be SNR rate. Any one of those values in there is actually going to make the decision. So at that point, I need to scan. I need to find another AP to connect to. And by the way, there's different ways you can do that. I can actually scan before I deassociate, or I can scan after I deassociate. Once again, lots of different types of clients out there that have lots of different types of capabilities to be aware of. So if I want to look for a new access point, I can do a pre-discovery. Before I actually am in the roaming stage, I can look at the environment. I can say whether APs are out here, whether they're using my SSID, what are they in my environment. That's a great idea because it saves time on roaming. It's a really bad idea because actually I lose connection on my channel while I'm looking at these other channels. So if I'm going to go and look at, I'm in a mixed environment, 2.4 and 5, I could have 20, 21, 22 other channels I have to look at to try to figure out if an SSID I'm looking for is over there. How long do I have to spend on each channel? What's a beacon interval? You guys better all know this. 100 milliseconds. So I got to stay there about that time. So I have to stay over 100 milliseconds on each channel. Probably a bad idea. That's a passive roam type of environment. The other is an active roam. I go to this channel, I send out a probe, should get back to me with 10, 20 milliseconds, whatever. Kind of a faster way to do it. But once again, there's a problem associated with this. What if I'm on a DFS channel? What if I'm connected on a DFS channel? I'm not allowed to leave that channel to see what else is available in other channels. A lot of challenges associated with roaming that we really don't think about. The other thing is, once I determine the target, how do I determine who I want to roam to? Most of the time, it's a stronger RSSI. That's one of the things that we need to deal with and fix that. And then finally, I have to roam. How do I roam? Once again, as crazy as it may seem, there are different clients that do different things. Some actually just leave, which isn't really a roam. If I've got an AP and kicks a client off, is that a roam? No, it isn't. It's just being kicked off. A roaming is actually a process where I do a deassociation. Once I do that deassociation, some clients, that's when they start looking for the next AP to join. Probably not a good way to do it, but once again, that's one of the options associated. And I'll eventually find a good client to associate with. Then I'm going to send an authentication request to that client. I'm going to get authentication response. Then I'm going to do an association request, and I'm going to get an association response. And then depending on the environment, depending on what kind of security I'm using, it's either open and it's real easy, it's pre-shared key, not too bad, or it's 802.1x or it's EduRoam where I don't know where that authentication server is. So how long can that take? 100 milliseconds, 3 days, whatever it's going to actually take to pay them whether it is. And that's the problem. That's the problem. Most of this other stuff, I don't lose sessions with most, but this is the problem if I have to re-authenticate and go through the process. So that's what we're trying to fix. Then you get the four-way handshake, then you get connected. And by the way, there's also a backup, there's an additional part where typically if I connected to AP2, AP2 is supposed to send a message back to AP1 saying, hey, by the way, this guy roamed over to me and send me all the buffered frames you have. Not a lot of people do that, but actually it's mentioned in the spec, but nobody tells anybody how to do it or if they even have to do it. At the same time, I have to tell the switch I'm connected to that update the forwarding table, send all that information to me. So that's kind of where we are today, that we just walk down the hall and it connects from one to the other. That's why we have a lot of problems associated with it, roaming. And the biggest problem is the clients are making the decision. The clients decide when to roam, where to, for the most part. And so that's what we've been trying, and I say we, the industry, have been trying to fix for about 21 years now. You know, Wi-Fi 802.11 came out in 1997. So we've been working on this for quite some time. So how do we fix that? Or what do we do with that? Oh, that got messed up. A lot of different things we've tried to do. Obviously, we had some proprietary stuff came out. Cisco did some neat stuff. You had opportunistic key caching. Maru had a great idea. Who's Maru people? Raise your hand. Don't roam. Don't let the client know they're roaming. Put everybody on the same BSSID, and they don't know when they roam. It's actually a really good idea for time-sensitive applications, not so good for high-density type deployments. But it is kind of a neat way they did that. But then the standards organization came along and said, we got some great ideas. 802.11e, F. Anybody ever heard of F? Come on, let me see a hand. One hand, two hand. I think Cisco's the only one that even tried to do it. That's the only standard or spec I ever saw that was withdrawn. People gave up on it, that it just kind of didn't go where they wanted to do. You had 11i, you had 11u, you had 11k, you had VR. Now you got AI, which is fast initial link session. You got 2.21. How do I roam between technologies? So once again, there's a lot of effort associated with this, both in the IEEE and the Wi-Fi Alliance. The Wi-Fi Alliance, I'll talk about this before, the Voice Enterprise and Advantage, and there's probably another half dozen other work groups involved that all have fast transition part of their solution. Because once again, we're at the point now, and I'm not going to say Wi-Fi is fast enough, but it is. It's fast enough, there's enough good enough stuff associated with it. Now it's making it seamless, make it more reliable. You know, if you look at what's coming out last year and this year, you had AX, you got WPA3, security, performance. Now let's make it a little bit more better user experience, improve the experience. And that's what these standards are trying to do. And be aware, every vendor's on a different page. I'm not saying every vendor, but be aware just because one vendor, whether it happens to be an AP vendor or whether it happens to be a client vendor, just because they're doing something, it doesn't mean everybody else is doing things the exact same way. Just to let you know, about 6 months ago, we were working with a customer, and they had a different person's APs mixed with our APs, and we had all kinds of problems. Just because we were both doing R just a little bit different. We were both doing it legally according to the spec, but we just did it a little bit differently, and it actually caused some interoperability issues, which is why you guys get the big bucks for troubleshooting, and you learn a lot more about doing traces. But that's kind of where we're at today. So, coming along, 11 KVR came out in 2004, or 2008, 2011 is pretty much when they showed up. Support of real-time applications. How can I make this seamless? How can I drop as few packets as possible? If you look at what the Wi-Fi Alliance tried to do with Advantage, they said, you know, loss of under 50 milliseconds, jitter of under 50 milliseconds, loss of less than 1% packets, no more than 3 packets lost in a row. Pretty strict requirements as far as that's concerned. So that's kind of what they were trying to do. Packet loss, latency, efficiency, sessions. I can't emphasize enough that when we talk about KV and R, that when we're talking about that, for the most of us, we're talking about how they assist roaming. There's tons of other functionalities that was built in that. So as I said, there's hundreds of pages in each one of these documents, and we're just touching on the very high level. Really important to realize that a lot of that stuff, if you read through every page, you're never going to see all of it. So just be aware of it, that we just try to make things a little bit better. So 11K, resource management, tries to make life easier on you, tries to make it simpler. Okay, I need to roam. Where should I go? Well, typically the client's going to look around and say, well, there's a stronger AP over there, there's a stronger radio over there. I don't know anything about that. I don't know the load on that device. I don't know the performance on that device. I don't know noise levels. I don't know anything about that device at all. So the whole idea of K, or one of the ideas about K, is for me to be able to get choices before I actually do it. So instead of having to go off my channel and scan, either passively or actively, for other SSIDs, or excuse me, for other APs on my same SSID that I might want to join, the idea is, can I just ask somebody? Can I just ask somebody and they can give me this information? So that's what 11K is really all about. The ability that the client now, I can ask my associated AP and say, hey, I need to roam. What's around me? Once again, there's some different vendors do different things, how they gather this information. If I'm talking in a controller-based environment, controller connected to a bunch of APs, that controller has a good view of the environment. They're getting information from their APs, they know what's going on in there, and that controller can send you out what's called a neighbor packet or a neighbor message. and say, this is your neighbors, this is kind of maybe your, the signal strength of them, this is, you're reachable to them, they're using your same security functionality, they're all using the same 5 functionalities you have, so this is a candidate for you to roam to. If I'm not in a controller-based environment, different vendors have different solutions. Within Aerohive, our APs talk to each other with protocols ACMSP and AMRP, and we learn that same information. So somehow, some way, the AP is going to be able to gather and build a database of this. The other part about this is in the actual 11K standard, the idea is it's supposed to be reactive. So when a client asks the AP, what's around me? What can you tell me about? At that point, the AP is actually supposed to build the database. In reality, that database is probably already built. They might refresh some stuff, get some different information. But the whole idea is to build that information up, neighbor notification, and send that information back to the device and say, here's your choices. With 11K, the AP is not actually telling them where to go. They're just saying what's available. It's really designed to, save scanning time, more efficient usage of the air. People even say it's more efficient use of, better battery management. And assuming, if I've got to jump and check 20 different channels and probes on each and listen, yeah, it's a little bit of better management type functionality for that, but totally is better. So better roaming, better searching, better capabilities, all that type functionality. The other thing about 11K is what everybody thinks about is a neighbor report. The clients gather an awful lot of information, and they can push that information up to the APs. What the status of me is, what's happening on my network, what's happening on my channel, what beacons I'm seeing from other devices. All this information on the right, this is what's gathered with 11K. Problem is, a lot of people don't do a lot more than just a neighbor report. So it's important to understand that, as I said, when you're looking through this and seeing, wow, I could find out all the other beacon traffic that everybody, well, yeah, theoretically I can look for that, but I'm not. I can actually see the station statistics, the location, configuring multiple BSSID type functionalities on there, transmit power control, stream category, link measurement information. That stuff was all built in there. Once again, if you've ever been involved in writing an IEEE spec, obviously everybody's got their little baby they want to get in there. And when something comes along like resource management, they put all that stuff in. But for the most part, what we're really focused on is a neighbor report. A neighbor report is just the idea to kind of see what's happening on the network. So this is really what's going to happen. Clients associate to AP number 1. Client decides to roam based on whatever their internal functionality tells them to do. Client requests a neighbor report. So it's going to request this from its associated, the AP it's associated to. The AP is going to build that report, AP, controller, switch. There could also be vendor-specific information. There's other stuff that can actually go in there. So there's a lot of open fields available. And it's going to send that down, and it's going to have the information of the SSID, the APs, the channel, the RSI, all the information the client needs to know. Now the client, once again, is going to make the best choice. Mind you, all I know is this information. I don't know at this point. Maybe there's 2 APs right next to each other, and I can roam to either one of them. One of them has a little bit stronger RSSI than the other. But that one also might be 200% overloaded on the radios, and the other one might have 3 people connected to it. I don't know that at this point. We might talk about that a little bit more when we get to 11V. But the whole idea is it's the first step. It's what it does. People are going to implement this more and more. As far as clients, iOS has implemented a lot of this. That was one of the challenges I had looking around is that, what vendor's doing what with the client side and the AP side, and it's kind of all over the map as far as that's concerned. So at this point, I'm going to make a decision. I'm going to roam, deassociate, do the authentication, the association. I'm up and running. Pretty basic type functionality. If you kind of step through. Neighbor report notification, this is kind of what the frame's going to look like. I'm going to get one of these for each essential, each BSSID or each AP I'm able to identify. Neighbor report, the MAC address, whether it's reachable or not, operating class, what it's doing, can I connect to it? Is it within my same ESSS? Is it within my same environment? Is it a real roam? A roam has to be within my same SSID. I can still go to another one, but that's actually not a true roam. The PHY level, all that type of information associated with it. And if you kind of look at this, it's kind of small, it's hard to see. Maybe you guys can capture one later day. Kind of shows you what it looks like in here. If you go up to the top under the red, you'll see BSSID. Then it'll give all the information about it, give what channel number it was on, PHY type, all this information. And with this, the client's going to make a decision. It's not a perfect decision. I don't know what exactly that client is doing, what exactly that AP is doing, but it's better than what I had before. And this is where we're going to go. We're going to go baby steps, a little bit at a time. Different vendors are doing things. Different vendors are offering different capabilities. All right, so I got all this information. I know a lot more about what's going on in the environment. Things are looking good. Now comes along something else. Comes along 11V, basically BSS transition. There's been proprietary protocols in the past that have said, you know, if I can put a software client on the client, I can control when it moves. Well, that's part of the idea of this, is I want to be able to see the environment. I want to make decisions. I want to make intelligent decisions. That's what 11V does. And it's important to understand, especially, you know, we're going to be talking about the BSS transition management, but there's a tremendous amount of topology information. There's a tremendous amount of multiple BSSID type functionality. There's a tremendous amount of other information that is in the 11V standard that very few nobody leverages all of it. They just don't. So different vendors leverage different things. But the whole idea, once again, is where K is really designed to speed up a decision making. V is really designed to help you make a better decision, is probably the best way to say it. So if you look at this functionality here, it's not only roaming related. Once again, we keep focusing on roaming with KVR, but it's actually more to that. Allows clients to exchange information. The clients can tell the AP a lot more stuff. What am I seeing? What's around my environment? You see, I got this AP, and APs are sensors. They see the environment. They see what's going on. But every client that's attached to them sees a lot more information. What they surround an environment with. You know, an AP, a client attached to an AP might hear beacons from other APs that this one just doesn't know exist. So I want to learn what that whole environment looks like, location information, sleep modes, all this type functionality. For the most part, all we're really dealing with V, as far as what most people think about as roaming, and that actually has to do with kind of making some better decisions. These are the IV capabilities. Once again, the highlighted one is the one we focus on. All the other stuff is stuff people threw in there. And I don't mean that negatively in any way, shape, or form. It's a great idea. Within the Wi-Fi Alliance, there's actually a work group now called Data Elements. Has anybody heard of that? None. Okay, Data Elements is kind of like, what other information can I get clients to give me? And can I encourage them to actually do that? Once again, the more information controller, a network management system has, the better decision they can make on the overall network. So as you can see, there's a lot of different information up there. Transition management is pretty much where we live. So what happens with this? What is 11V going to do for me? There's a kind of different things. There's what's called a solicited request, and there's unsolicited requests. The solicited request is pretty easy. Client gets their K information, they roam, they connect to another AP, and based on whatever they think, data throughput, whatever, they can actually send a request saying, you know, is this the best I can do? Is there a better AP out there that maybe has less load on it? Maybe it will offer me a stronger SSI, maybe a higher data rate. Maybe this RSSI is really, really high, but I didn't know the SNR was really, really high. So if I went over here with a lower RSSI, lower SNR, I can actually have a better data rate. So that's kind of the idea for it. So it's actually the client's, hey, point me in a different direction. Give me a better shot. Obviously very, very useful. The other three are what's called unsolicited requests. And this is where the AP, you try to connect to the AP. 11K says go to me. You try to connect to me and I say, I'm not your best choice. You know, why don't you go to connect to this guy for whatever reason? Maybe because I see what you're trying to do. Maybe I'm overloaded. Maybe RSSI, maybe data rates. I can do it for low RSSI. I can do it for low data rates. I can do it. I got enough devices on me. I know this AP 60 feet away has only got 17 clients on it. I know I've already got 512, which some vendors say they can support. Don't understand that, but whatever. That was a shot, I'm sorry. And then the last one is the AP 11V is actually positioned as advice to a client. It actually also has the ability to disassociate the client. 11V actually has the ability to say, hey, I think it's better if you go somewhere else. I think it's better if you go to this guy. You know, it's really better if you go to them, and if you don't, within the next 3 seconds, I'm going to kick you off. So it actually has the ability to do that. Most vendors don't actually implement that. Or if you do, you've got to have some system in place that after you kick him off, maybe he only wants to be on you, and you got to let him back or he goes on. So once again, this is kind of the whole process associated with this. This is the management phase. This is the functionality. But this is probably about 50 of the 500 pages in this document. So there's a lot of other good stuff hopefully coming down the pipe. You can't see it now because nobody's actually gathering this. I don't know what's gathering, but nobody's actually transferring this information, so it's very, very important. The last fast transition in Roman, 11R. 11R, as I said at the very beginning, when I got in, it was kind of exciting. Reading through this, and you got, once again, I like to ask questions. So, authentication and key management. How many people love that? 1, 2. Oh, did you say yes, or did you just point at him? And once again, I joke, but it is actually important, but it's the most convoluted stuff, at least for me. So, I'm looking at this, and I'm going to go through this, and the whole idea is that one of the biggest problems, if I'm in a secure environment and I'm roaming, that's going to be where your application breaks. That's where your session's going to break down, because, open, pre-shared key, even SAE is a little bit faster. It's probably not going to go an issue. But if I got to go through 802.1x each time I go to another AP, is going to be, obviously the client experience is going to be lacking. So you go through this and you look at this, and I actually kind of spent some time going through it. And what essentially happens, who's my 802.1 experts? I want to ask you a question. I want to see you raise your hand. Nobody. My God, I'm so smart up here, I feel. Or you're lying. With 802.1x, when I go through that whole process, I create what's called a AAA key or a master session key, right? Everybody nod their heads. Okay. That master session key then gets derived into what's called a pairwise master key. At this point, I can also tie in a pre-shared key, because your pre-shared key, whether you're WPA2, WPA3, SAE, whatever, that can actually come in. That becomes a pre-shared master key. Those PMKs then, when you get into R, become what's called PMK R0s, which get hosted on the authenticated device. I'm going to confuse you all, and then we're going to actually go through, because this is what I had to go through. They get hosted on the authenticated device. So the client and the authenticator. That authenticator could be a controller, or it could be an AP in a distributed environment. So now they both have this pairwise master key, or PMK R0. They then take those keys and create something called a PMK R1. Confused yet? Now I got PMK R1 and a PMK R1 here. If I'm in a controller environment, I take that PMK R1 and I give it to all my other APs, trying to give an idea how I can seamlessly roam. If I'm in a distributed environment, the first AP that does this, they have to have a mechanism to distribute that PMK R1 to all the other APs. Don't tell you how to do it, but you just have to do it. And those PMK R1s, they become your PTK, which is pairwise transient key, which actually you make your encryption out of. So once again, you can all pass the security. Close, right? Pretty good on that. That's what I read about 17 times before I figured out actually what they were talking about. But it's kind of important and it's useful to know. So let's kind of go through here a little bit. The whole idea of 11R is to simplify this. A lot of different words, a lot of different acronyms. It's kind of insane, but it's all designed so when I go through the first time, I associate to my first AP, I go through the whole 802.1x process, I get onboarded. Now when I roam, I want that to be seamless. I don't want to have to do that. And that's the whole process here. And once again, there's proprietary ways with opportunistic key caching, pre-caching, and all this stuff in the past, but there had to be a standard way to do it. So the idea here is, okay, secure, works with everything, no need to re-authenticate, benefits. Obviously, voice, multimedia, any real-time application, obviously, it's very, very valuable to it because you can't recover that stuff. I mean, non-real-time, if I drop a bunch of packets, if it's TCP, they'll come back. If it's UDP, I probably wasn't worried about them to begin with. So the whole idea. So this is kind of the step in a way what I just said, maybe a little bit. And I'm not quite sure who I stole this from, but if it was one of you people in this room on a blog, thank you. And let me know, I'll give you credit. The MSK reserved to the client subdomain thing. Pretty much what happens, the 802.x process creates a AAA key or an MSK key. Terms are used interchangeably, whichever you like, I have no problem with. This also, and that eventually gets derived into the pairwise master key, which once again works the same way with WPA2. Eventually you get a PSK at some point. The pairwise master key within 11R is called PMK R0. PMK R0 is hosted in the two people that started it, the client and the controller or the first AP. Those devices then create what's called, PMK R1. This is derived from that. And that gets distributed to the other APs. And then from that, I can actually create the encryption key. So now you can actually see what I said. So working through this in a much, much deeper, clearer way, and obviously these presentations are available for you guys, this kind of takes what I just said and what that just went and goes in depth, step by step. So once again, the first time I go through the 80210X, set all that functionality up, uses this, radius key exchange, get the first level pairwise master key. First level pass my key called the PMK-R0, sent to the authenticator and the wireless LAN client. Once again, the authenticator could be an AP, the authenticator could be the wireless LAN controller. Really doesn't matter to me, depending on which environment you want. It's a debatable decision. 3 levels, once again, PMZ0. PMZ0 only stays in the authenticator. PMK-R1, that's actually used to create the PTK, so a lot more information associated with that. Various levels of keys controlled by different people. Once again, as you can see, I got that, and the supplicant has the R0 on it. The supplicant and the authenticator will always have the R0, and they'll create the sub-level keys associated with that. Kind of talked about that already. The keys are cached on the APs. That's the key to all this. That once I get the PMK-R0, I turn it into PMK-R1. Those keys are distributed to the client. The client has it, and obviously the APs have it. That's the whole key point. With previous 802.11i, where you had pre-sharing of keys, you could only see one hop away, can only go backwards. They had some vendor-specific proprietary ones. This actually standardized the whole process. So once again, once I've got that R0 defined, once I have my mobility zone defined, everybody within that mobility domain, that's an AP, gets that R1 key, which means I'm able to communicate, I'm able to roam. And get through some of this stuff. PMKs are used to derive the pre-sharing. I talked about that. I'm going to kind of show the roam. And this is kind of what happens before here. Now, my first original AP's got that information. It sends the PMK-R1 via whatever back. I can do it over the air. I can do it over the wire. And by the way, this 11R actually works over the air or over the back end. The back end over the wired infrastructure is optional. Good luck. I don't mean that negatively, whatever, but it's up to you guys to figure out how to, or it's up to the vendor to figure out how to do that. It's not part of, it doesn't actually say how to do it over 802.3, but that's actually how that functionality works. Talked about that. So, non-roaming. This is kind of what we're going to have. I got it roam. I'm in a secure environment. I go up, I connect to the target AP, I go through the authentication, I go through the reassociation, and I go through the 4-way handshake functionality. This is kind of what happens here. And once again, this gets a little bit convoluted, but the whole idea behind here is add more acronyms. That's the key focus of 11R. So I'm associated to the original AP. I decide I want to roam. I've gone through this before. I've already exchanged either my controller or my original AP has already exchanged PMK-R1 with all the other APs. So I'm going to go in here and I'm going to generate an association frame. Association frame's got a few more things associated with it now. It's got a fast transition authentication algorithm. It's got a robust RSN, robust secure network. Information element with PMK-R0, with the mobile domain information element, with the fast transition information element, with an S-nunce. That's the station nunce. So this kind of looks like, if you look at the information here, it kind of looks like a 4-way handshake if you think about it, if you're familiar with that. And I send that over, because what I'm trying to do with that is I'm trying to say, is the AP I'm trying to roam to, are they aware of PMK-R0? If they are, then they're within my environment. If they're not going to give me the right reply. So what happens? He's going to reply back to me, once again, robust security, network information element, PMK-R0, MDIE, FTIE, A-nunce, S-nunce, and the R1. Now, I know that he's already got that information. So with that, what we can actually do is go through and do the 4-way handshake. Essentially, that's what we're doing. We're doing a 4-way handshake by any other thing. We go back and forth, the A-nunce, the S-nunce, the source address, the destination address. Once again, if you've gone through any of the four-way handshake stuff, all these terms look very, very familiar with you as far as doing. At that point, we're done. We're set up. It's done in 4, and it uses the existing 4 exchanges. It uses the existing authentication reply, authentication response, association request, association response. So once again, it's very, very simple and very, very easy. Anyone here chasing SAE very much or looking how that works? WPA3, SAE? No? You know, if you look at how that authentication works in that, they're doing a similar type stuff. Prior to all this stuff coming out, the authentication really wasn't very much. It was like, are you 802.11? Yeah, I'm 802.11. You know, the last time anybody used that was back in the WEP days. So then actually starting to use those frames, which are kind of, I don't want to say they weren't important, but they weren't doing very much. So they're saying, why don't we use that information exchange to do this instead of repeating it later? Once again, once I get the PMK R1, once I know that other client has, I can go associate over there. We can create a new pairwise transient key between that AP and the client, and we're up and running. Same thing. The BSS transmission, PSK authorization, once again, it works the same way. Because if you think about it, when we start to 802.1x, we got to the master session key, and that became a pairwise master key. We start with the PSK, we get to the pairwise master key. So it works the same in both ways. So if there's really not going to be much difference at all, essentially, is if I'm roaming in a pre-shared key environment or a passphrase environment or an 802.1x environment, as long as I support 802.11r. Going to be a couple more AKMs if you're interested. When stations go to associate to an access point, they exchange information about what authentication key management schemes can you support. Obviously, this adds a few more to that. So what's kind of happening now? Every vendor's doing their own thing. We've got something called 360. Once again, we're looking at this stuff. We're looking at data elements. We're looking at anything a client will give us and try to figure out how I can suck in this information in a standards-based way or proprietary way to actually make better decisions, because it's very, very important. Within the Wi-Fi Alliance, obviously there's a lot of different activity going on there, and pretty much almost all the certifications associated are adding some form of fast transition in them. So if they're not there already, there's actually action going on. Typically in the past, like 11R functionality, fast transition lived within the security task group, pretty much lives in there's a function living in every task group right now, so it's kind of interested. And as I said before, in hospitality and also in healthcare, I know there's a big effort going on right now in the client experience, the user experience. How do I define it? How do I improve it? How do I do things better going forward? As far as who supports what, iOS is doing a great job of supporting a lot of this stuff, K and V and R type functionality. Not all versions. I think 10.0, iOS 10.0 has a lot of this functionality in it. I'm not saying Samsung doesn't or Android doesn't or whatever, but there's so many different cases out there, you're really going to have to check it individually. This is something from a network management point of view, we are looking at as a company that if I'm having issues with the devices roaming or associating or whatever, to have the ability to say, okay, that's a XYZ device with firmware XXX, which I can gather just from looking at how they generate traffic. And then if I can have some back-end database saying, wow, I know this guy does not support 11R, so I got to assist that, or I need to make sure they get on an SSID that doesn't have 11R, because a lot of times an AP that supports it and a client that doesn't support it, sometimes the client just gives up, says, I do not like what you're saying and I'm not going to talk to you, which is not a good idea in a public environment. You know, if you control all your clients, you control your APs, that actually works pretty good, but just kind of be aware about that. So be aware of what's going on there. Summary, roaming's a good thing. Very few people don't want to roam. Association number 1, roaming is number 2. The idea of roam is seamless. Not many people care about nomadic roaming anymore except classroom to classroom type functionality. IVR goals is to simplify your life. Be aware there is going to be, what we're talking about right now is just roaming. There's a lot of other functionality. I think I beat that point to death. It's just a matter of, how do I say this nicely? It's forcing the clients to do it. I'll be honest, most of your AP vendors would love all this information, and we will implement it, we'll suck it in, we'll gather it, because we can use that. It's very, very useful to us, but depending on your Apples of the world, they're going to do a lot of this stuff. Your lower end stuff probably never will, and now you've got this whole IoT world that are going to have the cheapest possible chipsets and firmware, so how that works. But hopefully a lot of the IoT devices aren't really designed as roaming. They're stuck up on a wall, so they'll do that. Vendor-specific solutions, you're always going to see them. They're always going to be around. And that's it. Thank you very much.